recording now. All I need to do is get this thing working. What's it waiting for? Oh. Okay. That's actually from last time, I think. Yeah, it was long division. So, basically my function is going to be like this. If I have something like this, y equals x squared plus 2x minus 3, okay? Oh, that's okay, but how do I, graph it? Well, I'm always a fan of doing this, right? Notice that if I cover this up, that's just a line with a slope 2. So when x equals 0, what's y? Hallelujah. But now, because that's an x to the second power, they're going to have two x-intercepts. Now, how are you going to find it? You have to accept y equals 0. And how you're going to find it is how we used to find it. It was easy when you set x equal to 0, but what happens when you set y equal to 0? Now you got this thing entangled because you have an x squared here and an x and a minus 3. So, we learned to factor this in the hopes of, that's why we're really doing it, in the hopes of finding two x-intercepts. As you're doing it now, it's just a bunch of exercise, but really the goal, I think, in the long run, is to be able to solve these kind of problems, finding out where the x crosses. This is the highest degree of the polynomial. So the higher the polynomial, the more times it could cross the x-axis. That's the fundamental theorem of algebra. So here, I just happen to know that if I have a minus in the back here, then automatically it doesn't matter what's in front, it's going to be plus minus. If there's a minus in back. Got it? So that means I have to have an x and an x, otherwise I can't get back to x squared. And then if I have a 3, let's say, here and a 1. So you can see x times x is x squared, and then that's going to be minus x, and this is going to be plus 3x, and then this, it works. So these are the factors. These guys are called factors, right? Now I broke it up into two factors. Okay, why? Because when you have a product, that means one of these has to equal to 0 or you won't get a 0. So either 0 is equal to x plus 3, or 0 is going to be equal to x minus 9, x minus 1. Oops. So if you solve that, you're going to have two answers, right? Somebody say right. And this is x minus 1. So the two answers are, the set is going to be 3 minus 3, comma 1. Okay, now I have some pretty good information about how my at least graph's starting to look like, because I'm going like this, and I know that I have a y-intercept. These are capital X, capital Y. I have a y-intercept already here. So what goes in here could be like 1 and minus 3. See? I couldn't do it without the factoring. Set it equal to 0. Set the equation equal to 0, just like we did with the line. And so x is equal to, there it is, x is equal to 1. That's one x-intercept, and the other one's 3. And we know that the y-intercept's minus 3, right? So that means that this guy has to go through here somehow. See? And then it's going to go back up here at minus 3, right? So it's got to come down like that. Probably look something like this. You see? Where that would be the graph of f of x, which is a function of x squared plus 2x minus 3. That's what I'd like you to get out of it. because later on you'll be able to. Does it look that way? We can take a look, quick look, just to verify. So let's go back here, and I go here. Huh. I don't know why it does that. It like has to think about life. Okay. Looks like it wants to. Come on. There we go. I don't get it. Oh. What is going on? Oh. Okay. And here I had, just to show you if it's correct, y equals x squared x, and then I don't know if I have to use up arrow and then squared. Nope. So let's see, I go up here. Okay. And then plus, and then I had 2x plus, no, minus, right? Minus 3. Okay. So we can see, sure enough, oh, that doesn't look right. Did I? Oh, I know, I forgot the 2, didn't I? There we go, it shifted. Okay. So sure enough, here's the Y-intercept. It's at minus 3. Here's the X-intercept, 1. And the other one. So that's why I like you to know about factoring, because we use it eventually to find these things, which have important engineering. Could have important engineering or physics meaning. Any questions on that? Okay, that's just a little insight. Obviously we're not there yet, but we're headed kind of that direction. Okay. So let's go back. All right. Okay, so the rest of it is just like tricks of how to factor. You have to look at it and figure out how to factor. So on factoring, there are basically 4 principal tricks that we use over and over. And they don't always work either, but we'll try it. It's called it says this would be on page 4 Yeah, let's say starting at 422. Okay, we went through there. And now we did some long division, right? So now let's talk about sum and differences of cubes. Okay, actually the equations that we have to know are on page 428. On 428, you're going to see, I guess, 1, 2, 3, about 4 different versions. Okay, let's try those. Let's get rid of this. Okay, so first one was difference of squares, which is the most famous one. Difference of squares. And that's something when you have something like a square here minus another square. There's no middle term here, so automatically this is going to have to be a plus minus because you're going to have the middle term subtract. So I'm going to have an x here, an x here, and a y, and a y. Now, if you use your two horns, x times x, x squared minus xy, but look, here's a plus xy. So they subtract out till finally, right? And we don't know, there's no solution that we know of directly of the sum of squares. There is no factorization of it that we know of, or x squared. You know, we don't know this, for example. That one's, you can't really solve it right, because the only thing left to do is have a positive, right? Or minus, minus. But in each case, you'll have a middle term. If you have like terms like minus and minus, for example, that's x, and that'd be minus xy, and that's going to be plus xy. Well, it's going to go back to this. But if I had minus, minus, I'd have x squared minus, minus, and then I'd have minus y cubed. I'm trying to get this, see? So I can't get it. It just won't work. I can't get back to a plus here. X times x is x squared, and that's minus x squared plus x squared, and that's going to be a minus y squared. So, you know, you could swap it around so it doesn't matter. Just we don't know of an explicit way. However, we have this. X cubed minus y cubed. And that's the difference of cubes. Do you agree? Difference in cubes. You'll need these just to learn how to, all these tricks in factoring. And so this can be written as, turns out, as x minus y times x squared I think it's minus xy plus y squared. Okay. Now, we can check that out to see if that's correct factorization of a cubed. So let's try it. I'll just do a triple thick double horn. X times x, you see, is x to the third power. And this is going to be minus x to the second power y. And this is going to be a plus an x y squared. You see that? Now, this guy is going to be a minus x squared y. And this guy is going to be a plus x squared y squared. Or is that a plus or a minus? No, it's plus, because minus times a minus. And then I'm going to have a minus a y cubed, yeah? So I can see that, let's see, I got 2x squareds. My signs didn't work out, did they? This is a difference of cube. Okay. So the difference of cube, that has to be a plus. Okay. So our signs will change. We got x, and then I have, that's x cubed, and that's positive x squared y right here. And then that one is going to be a positive xy squared. That's okay. And then this one's going to be minus y x squared. There it is. And then this one's going to be a minus xy squared. So this one I can get rid of. Actually, I just need a difference in sign here, right? So what I got is, this is x cubed, and now this is going to be, or this is going to be yx cubed, or xy minus x squared y. And here I'm going to have finally, oh, it is going to be minus xy squared, right? So that works out because this guy subtracts with this guy, and this guy subtracts with this guy, leaving us x cubed minus y cubed. Okay? So that's the factorization of it. So now it turns out there does exist a form of the sum of cubes. And as you can imagine, it's going to be like this. X plus y, and then it's going to have, I think, an x squared minus xy plus y squared. Let's see if that's right before I go on. That's the sum of squares. Yeah. Does that look like it's going to work? It does? Well, let's see if it does. Let's try it. See if you can get it. What is x times x? What x times x squared? 3 copies. That's good. What's x minus xy? Well, it'll be a minus. What? X times that. X what? Do you see it? X is another copy of x. How about this one? Well, that's just going to be x times y squared, correct? Now, let's do the bottom one. Putting x first, I'm going to have x squared y. Right? Now, this is going to be a negative minus x and 2 copies of y. You see it? And finally, how many copies of y? Yeah. So let's look at the middle term. Okay, so this goes away with this. Yeah. And this guy subtracts with this guy. So are we left with the sum of cubes? Good. Now, I hope you realize after Thanksgiving, I think we only have 16 days to the final. So, and homeworks are way, way back. So I think people are hanging themselves with a long rope. But in the final exam, I'm going to want to have something that you factor and solve for the X-intercepts. Something like this. But I haven't actually done it yet, right? I haven't set the equation equal to 0 to find X and Y intercepts. But you're going to look at these different types and see if they apply to the problems that I give you so that you know how to factor them. Why do I want to factor? Because then each set can be set equal to 0. All right. So let's try one. Okay. I don't know. We could start anywhere. I mean, for the difference of cubes, for example, we can have, oh, it's easy, y squared minus 25. Okay, so that can be written as y squared minus 5 squared, right? And that's a difference of squares. And that can be written as y minus 5 times y plus 5. There's a difference of, yeah. Okay, and how about if I have, well, you got plenty of exercise here to do. That page 431 is full of goodies. That's okay. So you got plenty of homework, I see. Even every other third. Let's try this one. 27 and 64. So let's say 27 and 64 m cubed. And I'll put to make it different, I'll put here a cubed. So I got, looks to me like we may have something like this, right? The sum of cubes. So let's see, how can I rewrite 27? Well, I can read that as 3 to the third power, right? 3 copies. A to the third plus 64. Let's see, 4 times 4 is 16, right? Times 4. So can we write that as 4 cubed m cubed? We can? Okay. If you agree, then I can rewrite this one as 3a cubed plus 4m cubed. Okay, now that looks a lot like this, except what is x equal to? X is equal to 3a. And y? What's y equal to? Over here. Look here, and then look here. What is that? Yeah, and this x is going to be, yeah, so basically I'm going to replace this equation here with what is x. X is, we already agreed x is what? 3a. Plus we already agreed what y is. 4m, right? And now we want to take x squared, which was what? 3a squared, correct? Minus 3a times y, which is times 4m, right? Plus y squared, that's 4m squared, right? Now be careful because that's between the parentheses too. All of this is a parentheses. So just doing the multiplication to make it look like that form, I have 3a plus 4m times. Now that's the same as 2 copies of that, so that's the same as 9a squared, right? And this is going to be the same as, that's an a right here, by the way. So that's going to be minus 12 am plus 4 squared is 16. Whoops, 16 m squared. And then close the parentheses. So that's how we factor out something that doesn't look exactly pleasant, but we can see it comes into the form of sum of cubes. We got it? And likewise, you're going to have problems that are like this. Difference of cubes. But they're in this mold. Whenever times you see cubes, you start looking to see if the others will cube out. Any questions about that? So let's try some of these problems because I know you're aching to get them done. Let's try some more tricks then. How about number 45 on page 429. Somebody can read me that one. Okay. Yeah, how's that go?
49 times x squared minus 28 times x y plus 4y squared times.
Okay. First rule, and always the first rule in factoring. The first rule, any idea? Look for common. Anybody else know? There are no denominators here. It's all over one. Terms. So first you want to see if there's anything, in there like, well, they're not all even numbers. So 7 does 7 go into 28? 4 times 7? No, it won't go. I don't see, you can't pull out an x because there's no x here. We can't pull out a y because there's no y there. And then these, I'm looking for common terms between 4, 28, and 49. I don't really see it. So if there are no common terms, then you go to the next step. The next step, if it can be factored, like with tricks, it's going to be of this form. And if there's a plus sign right here, you always duplicate the sign in front. So it's going to be minus minus. And I'm going to have an x here and an x here, obviously. And then somewhere along the line, I'm going to have a y and a y, right, to get back my y squareds. But now, because I have number on the leading thing that's other than 1, it's 49. So now I have to look at factors of 49. Well, that's 1 times 49, right? And then 7 times 7, right? Anything else? That's for 49. Factors of 49. Prime factors. And then how about for 4? Well, we have 1 times 4, right? And 2 times 2? Okay. So I want to look at this multiplication terms of this and this that come up with 28 as the middle term. So you can see that 7 times 2 is 14, right? And 7 times 2 is 14. And notice they add up to 28. That's important. So that's telling me that I have to use a 7 and a 7. So clearly I'm going to have a 7 here and a 7 here, right? And now I got a 2 and a 2, so it's really nothing to decide here. 2 and 2. Right, so that would be the answer. Can we check it? We can, and go like this, right? That's 49 x squared, correct? And that's going to be minus, what, 14 xy? And this is going to be, and this is going to be another minus 14 xy, yes? And then finally I'm going to have a plus 4y squared, true? Now I can combine my middle terms, you see that? And it's in fact minus 28. Oh, good. Everybody's on time. That's great. Okay. So that's how we factor. It looks tricky, but somebody had to think about it. Factors of this and this that add up to this. I know what you're asking. You're asking, well, what if you can't find numbers that work? Well, I'm glad you asked, because there's going to be a way of solving those types too. Okay. Now, so maybe what I think, I don't know if you want to try more of these. Let's see one that might be looking kind of hard. How about, it just looks hard, but not necessarily hard. Oh, I don't know. Anybody have a problem they'd like to see? 42. One of the harder ones. Okay. Let's try number 42. Everybody got this written down? That wants to? Okay. All right. How does that go?
3y squared minus 48y plus 192.
That's it?
Yeah.
Oh, okay. I thought it was a harder one. All right. So, number one, are there any common terms? Huh? No, there's not a y over here. Oh, we can't factor out a y, because, I mean, we could, but we'd have to do, no, we can't factor out a y. There really isn't anything in common, right? So now I have to find what? Factors of? What and what? No, 3 and this to get this. So now I have to look at all the ways I can multiply to get 3. Well, it's a prime number, so only 1 times 3. But how about 192? Well, I know 3 can go into there, right? And that's 18. And that's 12, right? And that's 4. And I know that I can have, what, 2 go into here. And that's going to be 32. And I know 2 can go into there. That's going to be 16. Notice I'm only dividing by prime numbers. Those that can only be multiplied by itself. There's 8, 2, 4, 2, 2. So I'm saying that 192 has a DNA, can be written as the product of its prime numbers. It can be written as 3 times 2, 1, 2, 3, 4, 5, 6 of them. Now, why do I do that? Well, you know, it tells me how to get all the possible multiplications. For example, one solution is going to be, I can multiply, well, of course, 1 times 192. But this is 6 2's, right? So that's going to be equal to what? 64, correct? So here's a 3 here, right? So 1 is 3 times 64. Now, if I don't like that, then I can take this first guy, and that's going to be 6 times, well, now I have 3 times 2, right? So now I have 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is going to be what? That's another way. Or I can take, this is 6 times 4 is going to be 24, right? So that's 24 multiplied times 16. Is that right? Okay. 6 times 20. So I multiplied 3 times 2 is 6. Okay, and then another 2. Oh, this is supposed to be 12, isn't it? I knew there was something stinky there. What did I do? I just multiplying this. 3. This is a 2. This guy's. Okay, so that's 4 times 3 is 12. 12 times 24. That makes sense. Okay. So I got 2 times 2 is 4 times 8. Wait, this is 16, isn't it? No. Well, anyway, I got 12 now. So 3 times 2 times 2, that's 12. So this ought to be 16, isn't it? I'll get it. Okay. And that should be right. Okay. And now, if I take over this many, I have, that's 2 times 2 is 4 times 2 is 6 times 3 is going to be 18, right? Times 8. And then this guy is going to be 2 times that. Is that going to be 36? Right? Times 4. And then finally I have this where I'm taking that times 64, but I get back to this times 3. So all I did is I did this trick of the DNA of a number to look at all combinations. It'll give me all combinations that sometimes it's hard to find all the combinations when you get a bigger number, right? So now I have to look at factors of these, this times this, so that it adds up to 48. And so let's see. How about 1? 1 times 4 is 36. And then 12. How about 12? So 1 times 4 is what? 1 times 36 is 36, right? And 3 times 4 is 12. That would be this guy. That's kind of odd. So that adds up to what? 48. So if I have a plus sign here, what does that mean when I want to do the factors? What's a plus sign in the back of this trinomial mean when I'm factoring? Yeah, copy of the very first one. So so when I want to factor that, I just do it like this. And I know that it's going to be minus minus, because if there's a plus here, you duplicate this sign. If there's a plus sign here. Okay, so you know that eventually I'm going to have a y here, right, and a y here, just to get 2 copies of y back. Now, so now I have to figure out, I'm going to use these guys as my factors, this one and this one. So I'm going to put, if we look at y, I have to get 3 back, right? So I'm going to have the 3 here, and I could put a 1 here, right? See? So now I've used up that, and now what do I have left? Well, I have a 4 and a 36, true? Right here, I have to use those 2 terms. No? Is it working? Well, what's 3 times y? That's going to be what? 3y what? Yep, that's that times that. How about that times that? Oh, that's too big, isn't it? Oh, that's really... Well, now, okay, that's 3y times 36, right? That's already 90 something, right? Okay, so I don't really like it. So I'm going to try this. Let's switch the order here. And let's see if it makes it. So I'm going to put the 36 here, right, and the 4 here. So this stayed the same, right? But now I have minus 12 y. Do you see that? Now, how about this guy? I have minus 36 y. And then plus 4 times 3y. Is that right? So now I got 36 times 4. And 36 times 4 should be, if I got that right, that's 120. Is that right? Is it too low? 36 times 4?
144.
No, I need 192. So something's wrong here. That's not, see, 36 times 4 is 120 plus 32. That's 150 something, isn't it? That doesn't seem right. See, I doubled that, so that's that. And I went down there by 2. Right, I'm just saying. 30 plus 6 times 4. That's 120. And that's 24, right? That's where you got the 144. So this is not right. So is it 36 times 6 times 7. 7? 3 times 7 is 210. Okay, this is a mistake here. It's not 4. Is it even 36? Let me see. I hope so, because it had to add up. Hey, that's weird. It worked, didn't it? I made a mistake, but I used it. It still adds up to 48. That doesn't seem right. That was just lucky? Or unlucky? Okay, so what I had was, I had 2 to the 6, did I? When I split it up into DNA?
Yeah.
1, 2, 3, 4, 5, 6. This is a DNA of 192. It's equal to 2, to 2, to 2. And then I ended up dividing by, is it 3? So that's, yeah. Okay, so when I got 36, then that would have been 2 times 4, 16. That would have been 32. Uh-huh. 32. That should have been 32 times. What's left over here? 2 times 2?
12.
2 times 2 is 4 plus 3 is 12. So I already have 12 times 16, didn't I? Right here. So how about if I took all of these? So what's 32 times 2? 32. Okay, so here's 16, right? And then times 2. We'll make that 32 times 6. Is that better? Does anybody know what I'm doing? This is supposed to be 32. The actual factor that I just made one up should have been this, which is 32 times what was remaining. 32 times 12? No. All right, I got that. I already got it. So I guess I'm done, because the only thing left would have been going all of this times 3. And that was this one, 64. Okay, so that wasn't even a factor. Well, that really hurts. Okay, so let's get rid of that. I'm making this one ugly. Let's go back over here and make this prettier. Let's pick 2 more terms. That was weird. It worked out. Okay, so now I'm trying to get 48 again. Well, let's see. What's 3 times 8? Is going to be 3 times 8? Whoops. Yeah, or let me see. This, so let me see. So what's 3 times 18? Three times 8 is 24. 54. And then what's 1 times 8? Yeah, does that subtract out too? That was kind of lucky.
46.
Is it 46? Oh, it is. It was too lucky to be true. Let's see. So that was 3. Yeah, that's 30. Plus 28 is 54, right? 3 times 8 is 24. Okay. All right. So scratch that. Let's look at the next one. Okay. How about 3 times 12 is 36, right? So let me do 3 times 12. That's 12. 3 times 12 is 36. Do you agree? And then if I have 1 times 16, I have 16. Oh, well, that's not going to do it either, is it? Okay. Anybody see it? I have to have the right combination. What's 3 times 12? 36 plus 16, yeah. $36 times 12. So how about 18? Is it 18 times 8? 80. 18 times 8. Do I have that right? 8 times 10 is 80. That's not right, is it? No. Well, what is number is this one? I've already forgotten. That.
Yeah, 18 times 8.
Is that even right? 18 times 8. 8 times 10. That's 80, right? Plus 64. That's not right. How many errors can you make? So 8. What's 8 times? So how about 18 times? No, that's too big. So I got 18. How did I even get 18? Let's see. So if I went this way, 3 times 2. No, 2 times 4. I don't know how I got 18. So it should have been 2 to here, right? 2 to here. This should have been 24. No, that's part of my problem. It's just multiplying. Okay. So, and 24 times 8 sounds more reasonable, right? That's 20 plus 4 times 8. 160 plus 32. That's not right either, is it? Oh, is that what I want? Yeah. Okay. So, let's get rid of this. Little by little, I weave it down to the actual true answer. Okay. So I can see here what's going on. It's just from here on, it's multiplying by 2, right? So here I have 24. So question is, if I had 48, if I doubled that by 48, that would have to be equal to, well, this is what, 4? Does that look right? Yeah, because 4 times 40 is 160 plus 32, right? Okay, now I can start. Okay. All right, so I'm trying to come up with a middle term of 48. And so, oh, well, what's 3 times 8? Well, what's 1 times 8? That's 8. And 3 times 24, that takes us back over to
Or if you do it the other way, 8 times 3 is 24.
8 times 3 is 24 plus 24? Yeah. That'll add up. Okay. Tie my shoe. All right, what trip? Okay, so she was saying you could have 1 times 24 and 3 times 8. So let's see what we got here. Well, I still need my 1 and my 3, right? For sure. So now I need to have 48 and what else? What's the other term I'm going to use? The 48? Or was it 24 and the 8,
Yeah.
right? So 24 and the 8. So I can get rid of this. So somewhere along the line, I'm going to need 24. Over here, and 8. Okay, now we should try it. 3 is y squared, and 3 times that is going to be, that's going to be 3y squared, and now that times that is going to be minus 24 y, no, just y, correct? And then I want to have this guy is going to be another 24 minus y. And then finally, minus, I'm hoping that's 192. I think it is, yeah. And you see that this adds up to minus 48. Now, if I set that equal to 0, then I would solve for y here and solve for y here twice. Okay. So now, this was supposed to be easy, but it took quite a bit to see the different factors, and I had to do my multiplication correct. But you can see it gets a little tedious, but not too bad. They're kind of fun. And now, let's try one where it might not be, where there aren't any numbers that you can pick. What if I pick one where there are not any? That might be harder, or it's harder to see. I mean, it's not any combination of these numbers. Can it still be solved? Yeah, it can be. I'm glad you asked, because we'll try that. And we're going to call that one, this trick called, it's going to be called completing the square. So let me show you how to do it. And you always do it like this. This is complete the square. So let's suppose I have something like this. I have y equals x squared minus 2x. Let's say, let's say plus 2x minus 2. All right. You can see if I put my hand over here, that's back to a line, isn't it? So that's okay. So if I wanted to graph this, well, I'd put a little table, right? And when x is equal to 0, what is y? Yeah, hallelujah. I guess that's the only thing that's going to be learned in this class eventually. That when you put x in, the only thing's left is this last number. Okay, but now, because I have 2 powers, they're actually got to set y equal to 0 twice. That's why we factor. So I'm going to set y equal to 0 now and try to solve for x. But this is kind of complicated because the x is entangled both in the first and second term. Now, can we find factors of 2? Well, it's a problem because now we have, remember with a minus in back, it automatically means plus minus. Do you see that? Clearly I have to have x and x. And the only factors of 2 are 1 times 2, right? Is that right? So I don't know. You could try it. Let's see. 1 times 2. Well, x times x is x squared, right? But this is a minus 2x, isn't it? Isn't that right? So that's a problem. You could try to see if you could change the order. And suppose I put the 2 and the 1. Well, that's going to be x squared. And that's going to be a minus x. You see that? But that's going to be a 2x minus 2. So unfortunately, we're going to have a middle term of what? How many x's? 1x. Whoops. So it did work. These are not factors. Most of life is this way. It's not going to be easy. I mean, it's not going to be it's going to be factors of all the combined terms. That was just a lucky trick, but they try to promote your confidence by giving you some of these little ones. So my question is now how to solve this type of problem now. Now that we're in the deeper water, we're away from the side of the pool. How can we do that? Guess what? How do we do it? Who knows? Okay, you almost all said it at once. We're going to complete the square. Ta-da. Did you hear? Well, that was theme music. Okay. So now what I want you to do is I want to take this number here, set this equal to 0, then go x squared plus 2x minus 2. Okay, the first thing I want you to do is take this over here so that I have 2 equals x squared plus 2x, okay? Now, here's how you complete the square. You always take this formerly middle term, the coefficient of the middle term, and you divide it by 2. And then you add it over here. So what's 2 divided by 2? It's 1, right? So whatever this result is here, I want you to put it here and square it. Did you see? You always take your middle term, you divide it by 2, you take that result there and square it. Because we're trying to force it into a perfect square. Now, what you're going to say is I changed the equation. And I'm going to say, no, I haven't, because I'm going to add a 1 square here to keep it balanced. Are we okay with that? Okay, so now I have over here, but guess what? That can be factored, right? Because now that is, in fact, remember it's plus, you duplicate the sign in front. So you can write that as x plus 1 times x plus 1. See it? And that's going to be equal to, what's 1 squared? It's just 1, right? It's equal to 3. Well, anyway, the main thing is that you see already by completing that term and adding the square to both sides, it'll let me necessarily factor. So now I have 3 is equal to 2 copies of one of these. Okay. Now, on a side note, remember we're trying to get x by itself so that we can fill out these 2 spots, right? That's really what it was all about. So anytime you take the square root of a square, there are going to be 2 solutions. So if you take the square root of a square, so let's say that this is equal to, let's say, I say it's equal to 3. Let's say 9. Okay, what are the 2 solutions of x squared? Well, actually, that's not going to work, huh? Let me try that. Well, that could work, could it? 81. 81. So, yeah, so the square root of 81 is 9, right? So let's see. So x could be what? Plus and minus. Well, what is it going to be? You take the, so that's going to be x square root. So this would be 3. Okay. So what are the possibilities of that? So, you know, you can have either what x could be plus 3, right? Because 3 squared, square root is 9, or x can be minus 3 because it's squared again. Okay, so whenever times you take square roots, so I'm telling you that because this is like one big x squared. So I'm going to take the square root. So I'm going to take the square root of this side, and I'm going to take the square root of this side, knowing full well that eventually there's going to be two solutions, right? Because when you take the square of a square, there'll be two solutions, and you'll have like a plus and a minus. So the square root of a square just gets rid of the, right? Remember, square root, what does it mean? I'm not sure if I showed you or not, but x is equal to a fraction, x raised to the 1/2 power. That's what square root means. It just means x, you don't see it, but there's a 2 in the crack. So you're going to see the cube root of x, and that's going to be equal simply to x to the 1/3 power. And you're going to go that way until you have the nth root, we call it n, of x. And that's going to be x raised to the 1/nth power. Now, you can see that I can rewrite this as to the 1/2 power, right? This whole thing, I can rewrite this square root. I can rewrite it like this. Plus and minus, I can rewrite it as, you know, x plus 1 squared raised to the 1/2 power. Do you see that? That's what square root is, 1/2 power. Now, what do we do when we have power to the power? Do we add or multiply? What happens if I have x squared and I raise it to the 3rd power? I got 3 copies of x squared, right? So how many copies do I have? 6, right? So the shortcut is just when you have power to the power, you multiply. Okay? So guess what I have here? I'm going to take 1/2 and multiply it by 2. So what is 2 times 1/2? Well, you could put it over 1 and go skiing. And we did that perfectly so that we only get one of these guys out. So by the time we're done, this just ends up being x plus 1. But remember, we have the plus and minus in front. So, so now what do I have over here? I still have the square root of 3, right? And I'm saying that by taking the square root, I got plus and minus what? What's in here? X plus 1. So it doesn't matter. I can put this x plus y in front of the square root, right? Because it's just 2, whatever. It's going to be 2. Look at this. X plus 1. So when I subtract 1, what do I have? I have x. I'm going to subtract 1 is equal to 1 plus and minus the square root of 3. So guess what goes in here? Yeah, one of them is going to be 1 plus the square root of 3. And 1 is going to be 1 minus the square root of 3. We couldn't do it. We couldn't do it, so we set it equal to 0. We tried to factor. We couldn't do it nicely. So we forced it to work by completing the square. Take the middle term, squared it, add this, add that to the other side. Now the plus and minus look a little tricky. It really should have probably been on this side, but it doesn't matter. There's going to be 2 solutions. I showed you why. Okay, so that's called completing the square. Just take the half of this guy, multiply the square, and add it to both sides. And then try. Then it will automatically factor because you made it work. 1 times 1 is going to make, because you took half of that and squared it. So they'll add up to it. So what does that look like? Let's see if it's true. So let's take a look at the graph of that. Let's see what happens now. Oh, so the graph of that one was 2x. Good. I had this at minus 2, right? Correct? Instead of 3? So, okay, now let's take a look at it and see how this graph looks different. You agree that the y-intercept is still minus 2, right? Look at it right there. Now, let's try this. Okay, that's cool. Let's see. Those are my test cases. Okay, so now let's take a look at this. If I have one x-intercept is equal to 1 plus the square root of 3, right? And let's look at that. The square root of 4 is what? Anybody? Yeah. And the square root of 3, we don't know. But do we know the square root of 1? One. So you can see 3 is between 1 and 4, right? But it's closer to 4. So if you use your calculator, that might be something like 1.7 something. Anybody have the square root of 3? I'm just doing an approximation, right? Okay, and then add 1 to that. Add 1, right? 1 plus the square root of 3. Okay, so let's try that. See? So that was, okay, so that must be, let's try this one. That was minus, huh? Minus, what did you get, 2? What?
It's originally 1.73, and then you added the 1 to it, so that's 1.73, or I mean 2.73, sorry.
Well, was it negative or positive, though?
Positive.
Because that's a negative 272. Let's try that again. Okay, so I had 1 plus the square root of 3. And that's 1.7, right?
The original square root of 3 is the 1.7 plus 1
Right.
is 2.7.
So the other one was 1 minus the square root of 3. So that should have been 0.72, right? My signs are wrong. Why? The numbers are right, but my signs are different, right? Well, the y-intercept's okay. And is that what I had? X squared plus 2x minus 2? That was the equation? Let's go back over here. Oh, I know why. Because I did something algebraically here. It's got to be minus, yeah. Okay, let's see what I did here. So I got to here, okay. And I had 2 copies of that. Okay. All right. Well, wait a minute. Look what happened here. When I got rid of this, right? See here? So I have to subtract 1, right? To get x by itself. So this should have been minus. Yeah. And if you try it now, it's going to work. Because minus 1 minus 1.7 is minus 2.7. That was freaky. Anyway, you can see that we have our 2 solutions, which in fact matches up with where the cross is the x-axis. We cover this up. We've been doing a lot of this, where we find the x and y-intercept by setting y equal to 0, right? that would be equal to, just 1 if we're a line. But because we have an extra term, we need new tricks to solve for the x by itself. Okay? Okay, now, you saw how I completed the square, right? Okay, now I'm going to show you how to solve the problem for any polynomial of degree 2, a general polynomial. So before I do that, let's see if you have, let me try one more problem. Okay, suppose you have this kind of a problem. Okay, so suppose I have a problem of the sort where it's got a leading coefficient other than 1. So let's say y equals, I don't know, 3x squared plus 2x, let's say minus, let's say 2. So I would like to find the x-intercepts. Y-intercept's easy because you do your little chart and x is equal to 0, y is minus 2. But now I have to set y equal to 0, and since I know there are going to be 2 solutions, I set it like twice. So here's how you solve this. You do set y equal to 0, right? So 0 is equal to 3x squared plus 2x minus 2, okay? Now, the first thing you have to do when there's a number here other than 1, you're going to have to force and factor a 3 out. So watch. So if I'm going to force a 3 out of here, it's true that that's going to leave me an x squared, right? But it's going to leave me a 2/3 x here minus a 2/3. Look at that trickiness. Look what happens when I put my 3 here. It's okay. It's 3x squared. But when my 3 goes over by the 2, the 3 divides out, doesn't it? And over here too, doesn't it? So guess what I'm going to do? You're right. I'm just going to get rid of that 3 by dividing both, well, by dividing by 3. Do you see? That makes it handy because it just goes away. That's kind of pretty. So what do I have? I have 0 equals to x squared plus 2/3 x minus 2/3. Okay, what's the next step when we're completing the square? Anybody remember? We have to get the constant over. So I have 2/3 equals x squared plus 2/3 x. Okay, now what is the trick to completing a square? What do I divide by 2? Always this middle term. So can somebody tell me what 2/3 is divided by 2? Well, I can put that over 1, right? And I can whip it, right? So I got 2/3 times 1 over 2, right? Do you agree? So if you go skiing, do you see that I have, basically I have a third? Did you see? I took half of this. Half, because if I add a third and a third, guess what I get? 2/3. Yeah? So you take that guy which we will put in green, and add it, the square of the answer, 1, 3, square it. And to be fair, do it over here. You see? Somebody say you see that. So over here, if I have 2 copies of that, that's 1/3 times 1/3. That's going to be what? 1 what? What's a third times a third? No. 1/3 times 1/3. You go skiing. 1/9. Plus 2/3. Right? Now, you can do any way you want to do this, but this guy will automatically split now into, there's a plus, duplicate the sign in front, Okay? So x here, right? X here, this is a perfect square. And then this is going to be equal to, well, I'm just going to have a third here and a third here. And you'll see the middle term will add up to 2/3. Okay? Now, I can use a nose here, right, if I want to. So, if I do that, notice that I got 2 copies here, right? So I'm going to write that as 2 copies. X plus 1/3 squared. That's 2 copies of this. But when I use the nose, I'm going to put it over here, right? 3 times 9 is 27, right? And then 1 times 3 is 3, plus, and this is 9 times 2 is 18, right? Everybody agree that's 21 over 27? And do we have 3 go into that? 3 goes into 21, what? 7? And 3 goes into 27? 9. So, look how simple it's becoming now. Now we have, what? All of that equals 7/9. So, now I can do this. And I can say I have, well, I'm just going to make it look pretty. X plus 1/3 squared equals, remember plus and minus. Well, I'll wait right now. Plus and minus is going to be, because I'm going to take the square root. So let me just get rid of that for a second. And what do I have over here? I have the 7/9. But I'm going to take the square root of both sides. Remember, that's the same as taking it to the half power. And this guy, square root. So the square root of a square is just going to equal x plus 1/3. And that's going to be equal to, this can split up into the square root of 7 over the square root of 9, which is the square root of 7 over 3. So that's going to be plus and minus the square root of 7 divided by 2, right? To get x by itself, I'm going to subtract 1/3. Do you see that? So that's going to be x equals minus 1/3 plus and minus 7 over 2. Yeah, because the square root of that is 3. Okay. So what are the 2 solutions over here? We have 1/3 plus the square root of 7/3, and we have 1/3 minus the square root of 7/3. And if I graph it, you're going to see that this answer is pretty close to where the graph's going to be. Now, granted, it seems a little harder, and it takes a little getting used to, but all you're ever going to do is factor it out. So you have 1 here. Take the half of the middle term and square it, add it to both sides. It will then factor into something nicely that will make 2 copies. So when you square root it, you'll only get 1 copy of it, but there'll be 2 solutions, and those are your 2 x-intercepts. Okay? Now, let me just finish it off by showing you how to solve it for any kind of polynomial to the 2nd degree. That means 2. Okay? Bear with me, because it'll look hard, but it's really easy. Well, it's fairly easy. Okay, now what's the most general form that I can write? As a mathematician, I like to write it like this, so that I'm not worried. I want a rule that I can solve it all the time. So, but for what? I want to solve this kind, where I have ax. Now I have an a, not an actual number, plus bx plus c. Again, this is a line if I cover it up, right? And now I want to graph it, so I want to find the x-intercepts. Well, I still know that even in this case, when I got x and y as a chart, you know, when x equals to 0, you know, y is equal to c, correct? So now I have to find what? By setting y equal to 0, you know, I have to do it twice to get 2 x-intercepts. What are those? And if I can solve for that, I'll have an equation that will solve. We don't have to worry about factoring because you'll have an equation that will solve all of them. All you have to do is have this equation and plug in what A, B, and C is. Okay. So how do I complete the square on this one? What's the first thing you do? Well, you have to set y equal to 0, right? Because we're trying to find these x-intercepts, correct? Okay, so now, what was the first thing we did last time? This last example. Do you remember? Well, yeah, but first we had to factor out an a. Remember? Because we couldn't do it. So now I'm going to factor out an a. So I have 0 equals, and I'm going to take an a out, right? Leaving me inside x squared, right? But this is going to have to be b divided by a x, right? Plus c divided by a. Do you see that? Does that work? Because if the a goes back, it gets divided out, so it gets back to this problem. I forced a factorization out. Does anybody know what I'm talking about? I pulled an a out, but does it work? Yes, because you can put it back in. Okay, now, question. Well, the next thing I did, I divided both sides by a just to stop messing with that guy. So now I have 0 equals x squared plus b over a x plus c over a. Correct? Somebody say yeah. So now I'm going to take this over here. So now I have minus c over a. And that's going to be equal to x squared plus b over a x. You see that? Okay, so what's the trick now to complete the square? What do we do? What do we divide in half? And what is the middle term? The middle term is x squared?
No, it's
It's b divided by a is the middle term. So what do? We divide that by half. So we're going to take half of that, b, divided by 2a, and square it. This is exactly what we've been doing, but because we did it there, we have to do it over here. So here I have a b squared, the whole thing squared, divided by this right there. That's what, 2a? That didn't come out very good, but let me just take care of that. So this is 2a, right? Because half of this, half of b divided by a is 2a. Okay, are you with me? Okay, now, what does 2 copies of this mean? Well, it means 2 copies of b, right? 2 copies of 2 and 2 copies of a minus c divided by a, right? But this is going to break down real nice because now we got a solid, we forced this to work, and this is going to be x plus a b over 2a times x minus a b over 2a. Oops, sorry. Plus.
I thought if the original equation was with a plus, it would be plus and then minus. Is it
I haven't taken the square root of a square yet.
oh, okay.
That's only when that happens. When you take the square root of a square. So if I have x, you know, x squared, let's say, equals 9. Well, there are 2 solutions of that, right?
Yeah.
But if I square root both sides, one solution is going to be, what, 3, and then the other one's minus 3. Do you remember? Okay. So we need to get a common denominator right here, right? So, or we can use the nose, can't we? Could we? Okay, so if I use the nose, then I'm just going to multiply this times that. So, well, I don't really want to do that because that's not my... So all I really need to multiply here, this will be easier. What if I multiply top and bottom by 2a? And then that way I would have a common denominator, wouldn't I? I'd have 2. I would have a 2a squared on both sides, right? So I have a 2a squared. Let's see. Oh, this is wrong. It's not 2, is it? What's 2 squared? Right. So that means I have to multiply this by 4a and 4a. Sorry. Why? Because we already have a let me clean it up. I mean, we can, either way, let's just take a look. What would be easier? Let me start this back up. Okay, so what I'm saying is that I got 2 copies of B, 2 copies of 2, and 2 copies of A. So this should have been 4. Okay, so if I multiply this side, just to get one of these, I multiply this times 4, right? And another A. That will give me 4a squared at the bottom. But to be fair, I have to do it on top, so I'm not changing the thing. Okay? Somebody say yeah. So what I really got here now is 2 copies of this. See? This guy? X plus b over 2a. And that is going to be 2 copies of that. Ching ching. And that's going to be equal to, now, I have b squared. Right, so I have b squared. I'm just writing what I got over there. So I have b squared minus 4ac. That's on the top. See it? I just changed the order. And then what do I have down below? I have 4a squared. Do you see? I had a common denominator of 4a squared. Does anybody see that? Okay. All right. So that's looking pretty good. I'm still trying to get x by itself. Now I can take the square root. And when you take the square root, that's same as raising that to the half power, so that's half times 2. And now I'm going to take the square root of this. Okay, now I have x plus b over 2a equals, and then this is a plus and minus, and the top's going to be equal to b squared minus 4ac. And that's going to be divided by the square root of 4a squared. Can somebody tell me what the square root of 4a squared is? 2a, which is kind of nice, because this is going to be, so I'm going to have x plus b over 2a equals plus and minus the square root of b squared minus 4ac over 2a. Yeah? Now notice that's a 2a too. So I'm going to get x by itself. How am I going to do that? I'm going to subtract b over 2a from both sides. So now I'm going to have x equals minus b, right, over 2a plus and minus b squared minus 4a all over 2a. Do you see it? So that is the famous X-Intercept solution to all. So it's called the quadratic solver. The X-Intercept is equal to, okay, minus b plus and minus the square root of b squared minus 4ac divided by 2a. Now you don't even have to know how to factor. So let's just try it and see how it worked. We'll do it with the problem that we did previously. If you remember the problem that I did when we completed the square and we solved it, like minus 1 plus the square root of 7 and minus 1 minus the square root of 7. Do you remember that one? Somebody say they remember that. We just did it. Okay, so now let me just show you in action and then we'll be done. This is a little pushing ahead, but hopefully you'll be well prepared for the next class. Okay, so before I had what? y equals, did I have 2x squared? I forgot what I had. 2x squared plus 2x.
Which is x squared plus 2x minus 2.
No, I had a front term. I just did it, but maybe it wasn't. It doesn't matter. And I can change it a little bit. Let me, we don't have to solve the same problem. Remember, I had to factor out a number.
Oh, let's see, we got 3x squared plus 2x minus 2.
Okay. Like that. Okay, did everybody kind of remember this? I factored out a 3, I think. And anyway, in this case, look at this equation. So what is A here? Here. Yeah. You say that very cautiously. B, what is B? See, B goes in front of the X. 2. And what is C? Okay, so now I'm ready to plug and chug. I want to find my 2 X-intercepts, so I know it's going to be equal to minus B is minus 2, right? Plus and minus B squared. Why, that's 4, isn't it? Minus 4. What's A? 3? Times 3, right? Times C. And what is C? Minus 2. It is. Divided by 2A. Well, A is 3, right? So it's 2 times 3. Do you agree? So the possible X-intercepts are going to be minus 2 plus and minus. And here we're going to have the square root of 4, right? But here we have 12, 24, right? But that's going to be plus, because a negative times a negative. So I'm going to have 24 plus 4, right? That's going to be 28. Yeah? Divided by 6. Well, I don't know. It doesn't look like the same answer. So X-intercepts will be equal to, take the high road, minus 2, this plus sign, 28, divided by 6. And then the other one would be X-intercept, minus 2 minus the square root of 28 over 6. It doesn't look like the same answer I had before. Anyway, this should be the solutions, you know, when you do. Any questions? So a lot of people go to this directly and they forget how to factor, because that solves all the problems. And that's called theory of math. We took something that's completely general and found a general solution. How do we do it? How? How did we go from here to here? What was the trick? You know? What did I do to do it? I completed the square. Now, of course, this will work if this is just 1, right? You know, it's really easy, because A is just 1. Right? If you can do that, I say you can pass the class, no problem. Just kidding. But yeah, no, it's not that bad if you complete the square. Any questions? Is it too fun? I want you to go home plenty excited and tired.
So about the homework, we're doing every other odd.
Yeah? I guess that means we're done. We're asking about homework. Oh. What the? Oh, that's why. What the hell? Oh. It's going to come out there, you know. What the hell?